copying and pasting code. Okay. It's just showing you it's more about the connection between Arduino and Max and Unreal than it is. That's what's unique to this class, not really the fact that I'm going to flex and make like a robot or a synthesizer or something like that. That's not my forte. This is not my strength. But I'm really getting into it. I'm really liking it. So hopefully I'll get better at it. So here we have a dimmer. Okay. This is just an LED with your LEDs, and we have tons of these. Again, we have little kits. We have a bunch of physical. I can show you guys at the end of class. We have LED. We have the long end and the short end, right? So the long end connects to the voltage, and the short end goes to the ground. So I'm just gonna. I actually cheated. I do have one wire in here. I have one wire that's connected to, again, the ground, which is the negative. And I'm going to put my short in there. And then I need a resistor. It's 220. I don't really understand the whole logic of resistors, but I do know that they're color coded for 220. Again, not trying to wow you with my skills. I'm not trying to press anyone here. So I can make this one go from here to here to another. The whole idea is we don't want to blow out the LED, so we're trying to put a little resistance for the current. Is anyone super strong point doing physical computing here? Anyone a whiz? Anyone a whisper of Arduino? Okay, good. I feel a little better. It's like trying to like dance in front of like professional ballerinas or something like that. And now we're going to connect everything. So I'm going to put, this one says to go into ground with the black one. So the ground is over here on this side. I'm going to actually switch these sides. Ground, there I can connect it to. If I can feed it to the whole line. So up and down. I'm just giving all the way up and down. I'm giving ground to it, and then I'm pulling ground over to the blue one. Should have used a LED that's not white. You can't see it against the white thing. And then red, I'll try to keep color coordinated, goes from the resistor for right now to, it says pin 9. So there's a little 9. So I made my first LED circuit. Great. And then there's a document if you want to really get into it. This is where all these pictures came from. But if we open up Arduino, and again, you can install the software. It's free. It'll ask you 3 times you want to donate. And then I'm going to go over to update my examples. And then underneath communication, this is the part where we're going to go. Has anyone seen these examples? These are pretty straightforward. You could do this without even a LED. You could use just the onboard LED that's on channel 13. And we're going to say dimmer. Here is the Arduino code. Let's walk through it. Okay, so we're just going to be sending serial communication. The way we're doing OSC to Unreal and back forth, for Arduino, it's actually going to be called serial communication. It is has a rate at which we're going to be pulling, right? And so that's 9600 baud. And then we're going to establish that we're going to be sending data on, boom. So we have pin 9, that is a variable. And again, I'm not writing this code, I'm just copying and pasting. There's a happy hour, the media commons. So pin 9 is my LED pin that's going to be driving it. It then I'm reading it, and I am going to be writing to the serial the brightness, right? Whatever bytes I'm getting from Max. What's cool about this, if I scroll a little further down, I have code for processing. And if you go a little further down, you can see that I have Max code right here. All right, so I can grab this, copy, then open up Max somewhere. It's not pinned anymore. Let's go ahead and pin it. Pin to taskbar. Cool. And then I say new from clipboard, and I got a little patch that's supposed to drive that. Okay. This is thanks to Tom Wago and Scott Fitzgerald. So thank you, Scott, from 2006. Right. This is a little Max patch. We've already seen some of these components. We've seen sliders. We've seen toggles. And then these are object boxes. And then these right here, these are messages, right? So messages are M, object boxes are N for new, toggles are T for toggle, sliders are, I say new, but then I type in the word slider, and I have a slider. So here's how you create all these objects, right? And then it gives us instructions. We need to click to start. So I'm going to lock it up. I'm going to say, first thing I actually do is I'm going to find a list of all my serial ports, right? So I'm going to say print, and it says Arduino is actually on port C. Here's the serial object, and we want to send, again, data on a port through at a certain rate. Serial A is not the right port. I need to change this. This is a little bit of funkiness that's saying when I turn it on, change the port, and when I turn it off, close the port. I'm going to change this to say, can you override with the message of port C? So I turn on, it's now connected to the Arduino. I need to upload this sketch as is to my Uno, right? So it says Arduino Uno right here. It already recognizes it. I've already updated everything. It's ready to go. I'm going to upload. And it says it can't actually get to there because my Max is already connected to the serial. So let's go back to Max and then now turn off, which will close it. And now it has access to the port. Great. Arduino has access to the port it uploaded. Now I shut it off. I come back over here and now I turn mine on and I'm connected to the port. And then if we look at this LED right here, we'll see that I'm now doing this, right? So this is just out of the box. I learned how to follow the guide to put everything on the breadboard correctly. But if you can do one LED, you can do a strip of LEDs, right? And I didn't get to it because I blew out my RGB LED, but I left the code in there to show you guys how to do it. You can use the mood machine and do the RGB LED with the code too. And then you can do, like then it's just a matter of scale and how you want to brainstorm. Again, we're just doing proof of concept for right now, right? So great. We have now data coming from Max, and we already know from OSC a little bit that we might be able to connect that to Unreal. Let's do the opposite. Let's get data into Max from Arduino. So the next thing I'm going to do is go to photoresistor. This is basically a light sensor. Um, you can't see that at all. And I'm going to plug it in somewhere further on down here. Cool. And it looks like I need to take 5 volts and then plug it into one side. I think it doesn't matter which side. I'm going to do maybe a longer one, 5 volts, and then match it to one of the longer sides. And I'm going to power it, or I'm going to send it values over analog 0. So I need to connect some data to analog 0, but I also need to draw off some of the power, extra power to ground. So let's go ahead and connect analog 0. Oh no, the thing broke. That's fine. All right, so I have uh analog 0 is connected to the photocell. Back a little bit. It's all flipped in my head, which makes no sense to me. Why is it like that? There we go. Oh, let me focus again. Great. So photocell, maybe I can put these a little further away. So 5 volts is going into one side of it. The other side is going over here. And I'm going to try to find the right resistor, which it's too dark for me to really see. So it blows up. That's fun. That's red. That's red. It's probably the one I lost on the ground. These are all labeled. There we go. There's brown. This one goes to another pin. And I'll connect that to ground. All right. So again, with the link to doing the Adafruit, right? Which is if I just do photo cell, sorry, Arduino. We can see how to line it all up. Oh, this one does actually what I'm going to be doing in a second, connecting them all together. That's fun. But I had to teach myself how to do it from scratch. Right. I should have gone here first. Too much fun. All right. So this is what we're doing right here. And I have the code and presentation. Can I edit from here? There you go. Cool. So photocell. Where did I get the code from? That's how I wired it. Yes. Let's do that presentation. I forgot where I got it, but basically, we want to basically establish a value that we're sending over print instead of analog writing, which is we're going to bring it into the Arduino. We want to take it out. We want to print it to the console or grab it over serial, right? So we want to get this value. I already have this right here. Again, very simple. I need to go back to Max and close it so that I have my port available, and now I can upload it to the Uno. And now I have the new code that's up there. And then how am I going to read it? Well, it's the opposite. We need to actually, instead of pushing things in the serial, we need to get things from serial, right? So I will share this on week 5. Unlock it, select all, copy compressed. I have to turn on my trial. Great. Sure. That makes me happy. And now we can copy compressed And now you guys have the photocell information on physical computing. Great. Which again has that code for the Arduino. Essentially, the serial object, if you go to the help, can both put things in and print things out, right? Uh, From here, it has line returns. So that's the ASCII for 13 and 10. We want to make sure that we understand and then chop things off after the end of every carriage return and convert of everything to numbers from the binary. And so this is just a block of code that whenever you see serial coming from Max, from Arduino to Max, it always has this following each other. And so we just copy and paste that, and then we should get values from here. Okay. I'm going to now, we have open and close here as well. I'm going to open this data. But it needs to be polling constantly. So I'm going to put on a metro that'll be ticking it. So this is at every 20 milliseconds, it's polling for a new value. And you see that I have 700 here, right? So 700, and my light is getting a value of basically 0 to 255. I'm going to use an object called scale. This is its remapping. New scale, and I want to scale 700. And it seems to go down to around 300 or 400. All right, we're getting these values. At 700, down to around 300. So scale 300 and a point to keep it floating, 700, but it needs to be 0 to 255. So take this value that's coming from here, drag it into this number box, which is then driving my light. And it should, oh, well, that's because I don't have the Arduino code for connecting together. We've just seen that we can now get data from a photo cell just from copy and paste this information. Great. Let's go back to the Arduino code and put these two patches together so that we can do both things at once. We have the photo cell and we have the dimmer. We want to do a photo cell dimmer, so we're doing both at the same time. Let's do a new sketch. And I'm just copying my pasting my way to success. We'll start with this one, which is the photo cell. And then let's look at this dimmer code because it's more complicated. So at the top, before we do the setup, let's establish our variables. Then let's look at the setup. They're saying serial begin. That works for me. And we just need to establish what pin we're using for the input. So there we go. And then in the loop in the draw call, they're establishing analog read as the value. We're also going to make sure that we're talking about the brightness. So we're just combining these together. Right. And then we're saying if serial is available, go ahead and write this stuff. Great. So just copy and paste them together. We'll call this one combo and class. And let's see if it works. I'll go back to Max first because I need to close that port. And let's upload it up. That's promising. Cool. So we're now going to open this, and we're still getting values, right, on there, and we're still getting a dimmer, right? So if we're getting live values from the photocell and we scale those values from, we see it's from 700, 300 to 700, and from 0 to 255, we can now put this into this number box, which is then going to send it back to serial. And there we go. So I'm now connecting those two things, but it's running through Max first, right? So just not trying to wow anyone of my skills. I was just happy that I did this on Monday, and I'm like, okay, I approved it. What's interesting is that I'm sending it in and out. I just don't have control over the lighting situation here. Great. So back to the presentation. Uh, you can imagine then, again, I have the code for this and I had it working, but then I blew it out, so I can't show it to you on a broken one. I bought 100 of these, so we'll have enough if anyone wants to play around with Mood Machine and connecting these. But essentially, you just take the code for that, and then you're just writing 3 lines of serial in there. So the next thing I want to talk about is relays. I love this LED light so much. All right, so we're gonna take a quick little detour. If anyone's interested in VJing, which is super fun to do, oftentimes you need to get an audio source, right? So I'm going to show you a couple new objects. So new, we're going to get a microphone. We're converting I'm an analog thing to a digital thing. So we're going to do an analog to digital converter. There's a one that has a really cool icon of a microphone called Easy Analog to Digital Converter. And there it goes, microphone. I want a microphone. That's all I'm saying. Now I want to look at the data at the frame rate of video, which is 30 frames per second, which is also known as 30 every 33 milliseconds. So I want to look at the peak amplitude of my audio signal every 33 milliseconds. All right. From here, I'm going to get a value. Let's turn it on. All right. So I'm seeing that I have some values. It's kind of hard to see what those values are, but you can see that they're moving and shaking. Um, this is super fun. New object, not a slider. We're going to use a multi-slider. Multi-slider, it can go both ways, right? It goes ups and it goes down, right? But it also has a couple of things. It does a line graph. If I go over to if I make it a little smaller, and then go over to my inspector, inspect it, go down here to the settings. I don't want it to be a thin line. I want it to be a line scroll. Right. And right now the range is from -1 to 1. If I go back over here to my values to like dip in and take a look at it, it looks like it's pretty much 0. And if I'm at my loudest, almost at 1. So 0 to 1 sounds better to me. So instead of -1 to 1, sorry, over here, let's go to 0 to 1. And then if I put it here, you can see my audio. Cool. So when you're doing VJing, you oftentimes want to know exactly when something hits, but you need to trail it off so it's a little more smooth. This is too jagged of information for us. Like, so usually you want to like do an EQ and just find like the bass or find the snare, and you want to trail off. You want to smooth the data. That's known in Max is called slide. You slide the data. So we're going to use a new object called slide. And it says, what is the slide up? We want to be immediate. So at 1 millisecond, then we could trail down over the course of 20 milliseconds. And now take a look at that. It's much smoother. And you can actually see values linger a little bit. That's usually what you want to do when you're doing live show control. So cool. So we have values now of 0 to 1 doing this, but this is a value it's kind of, yeah, from 0 to 255. So we could say new scale object from 0 to 1, make the new values be 0 to 255 in there, delete this one, and now I'm audio reactive LED. Cool. I like it. Sorry, just had to go on a little tangent there. So we're sending values to and from. These are like floating points or integer points or whatever, but we also want to do another thing, which is actually even more important for this class, which is we want to talk about relays. I don't know if anyone ever used relay. They're electromagnetic switches, right? They use things off and on. All right. So whenever you want to find, like, you want to find a thing like a fan, like this fan. This fan, which you don't have to see because it's loud as shit. When it's on, you can hear it. It has a hardware switch, right? So if I unplug this and I plug it back in, it just starts working, right? So that hardware switch is always on. It's not a software switch. So think about all the electronics, fans, heaters, things that have hardware switches that you can turn off and on. We're going to do that with relay instead, right? So I don't want to mess with that cord. That cord's way too loud or way too much power, and I'll electrocute myself. I don't trust myself with electricity, right? So when we want to mess around with that stuff, we put a relay. So we're messing around with a little microprocessor and dealing with a relay, and it's not, and we're just impeding the power from getting to its source, right? So a relay is essentially magnet, and it switches an arm and it makes contacts with a spring, right? So springs open, springs closed. I've always thought this was kind of like the inverse of what I thought. This circuit right here, again, electromagnetic spring, arm, contacts. This circuit right here is this open or closed. It's now open, correct. Does electricity flow through? Open means it doesn't flow through, right? Because it's not making the contacts, it can't go through, right? So when you send a value to this little arm, it swings closed, and then you have voltage. And when you take away that power, it then opens back up, and that's a relay, right? Right. So you have two different circuits. You have the control circuit that then deals with the load circuit. The load circuit's what's getting from the fan, and the control circuit that's completely separate, that makes me safe to work with it. It's on my Arduino, right? That's a little toy thing that then powers. This could be a rocket ship. Doesn't matter, you know. It's just I'm allowing the voltage to go through. I'm maintaining my safety. So you have two different kinds of relays. You have normally open, normally closed. Think about it. Do you want your thing to always be on? Do you want to turn it off occasionally? Or do you want your thing to always be the opposite, always be off and then you turn it on occasionally? Most of the time, we want things to always be off and we want to turn them back on. But people use these things for non-creative pursuits. They might want it to, run their Wi-Fi router. They want to use it as servers, so like that. So there's different reasons why you'd have different ones. We're using one, and everyone honestly should get one of these. They're 15 bucks. It has 4 ports. One of them always works. So that could be your computer. That could be something that always needs to be on. Then it has two that are two that are normally off that you then turn on, and then one that's always on that you want to turn off. Right. So this is a company in San Francisco called Digital Loggers. And this is we used to call them power switch tails, but this is the company to go to. It's called IoT Relay. And totally read the reviews and you'll be astounded by all the different use cases that people use for these things. People have these like in the Antarctic and they're doing things with like there's all over the world doing really I'm like we're using like why doesn't everyone just use it for amusement park rides? And they're like, you guys use it for amusement park rides? We have our entire server, running on this stuff. So these things are really, really well regarded. The $30 now, they've been cheaper and they're by a company called Digital Loggers. Cool. And what it has is these little two wires. Actually, what's cool, it has a little terminal. I can actually pull it out, yank it out, right? And then I have little screw heads, and I can put in these two wires, screw it in real nicely, plug it in, and then one basically goes to pin 9, and the other one would go to ground, right? So this is a relay, right? And again, we have 4 different things you could do with these things. What's cool is this is also a relay, and each one of these is individually addressable as well. So start thinking about all the things we could turn off and on, and this one's over Wi-Fi. This one's also controlled via Max, and I'll show you that in a couple of weeks, but we're leading up to this one, right? So for right now, we're going to do fan. I want my fan to normally be off. So that's the 2 right here. And then I plug this one into power. This is going to get complicated in a second. Or not at all. There we go. You're plugged into here. Cool. And then I'll bring old Arduino. We've already established that this stuff works. Undone. Don't care. I'm just going to plug it into ground. I forget which one's which. Negative goes into ground. And then positive, we're going to use 9, pin 9. So now if we go over to Max, for right now, save this. We'll come back to it. Let's go back to our friend, the dimmer. All right, so just the simple dimmer. We want to now send in, well, we're just sending it, not an analog, we're sending it just to off or on. But for right now, let's do this. It's done compiling. Let's go back to the code, start from scratch again. New from clipboard. We know that we're port C, not port A. And let's turn it on. I don't think I have any errors. Okay. Now, it turns on the fan. It's turning off and on more than just the fan. So I turned it off. It's happening at some point between 0 to 55, but we're not sending analog values. We want to turn it off and on. We're just making a mistake and it's working. So my quick sleuthing of this was we just need to change analog right to digital right. This is just me on Monday having fun. Oh, so I need to close Max again. Good to know that. Upload it. And now on pin 9, I can do a toggle. Analog is sending a series of values going, so dimming up and down, 0 to 255. Yeah. Yeah, true or false. Yeah, it's just binary, right? Analog is faking that. I mean, we get the pulse width modulation and the fact that analog is just a series of off and ons that happen slower and slower or faster and faster. And that's its own conversation of, do you guys know pulse width modulation? Oh man. Pulse width modulation is the way Arduino's faking being an analog thing, but it's not analog, it's digital. Yeah, it's pulse width modulation. We'll get a little graph here. So the longer it's on, the more it feels like it's brighter. And when it's on for shorter, it seems dimmer. And that's how it's faking a digital thing actually looking like it's analog. The guy who invented this did it for his master's thesis. His name is George Mueller. He invented the RGB LED back in the 70s, and he made a company called Color Kinetics. Philips Hue bought Color Kinetics. It's what like drives the Empire State Building. The colors on this guy named George Mueller. He got paid $976 million for his invention. What do you do when you have $976 million? He invented art cars at Burning Man. He has a company. He's over Morgan Avenue, Williamsburg, and he runs a thing called Robot Heart. He actually just died a year ago. This is 60,000 watts of speakers in an LED wall that drives around the playa at Burning Man. I VJ'd this thing before at a rave. And I met George when I met George Mueller. Anyway, so he invented pulse width modulation for his master's thesis. Um, and then just was like on ecstasy for 30 years. Anyway, that's all recorded on my screen recording. Anyway, so the idea is that we're sending, let's click to start, on. I love that I'm turning off the projector. Off. All right, cool. So this makes sense, and we have a few more moments left. So let's do the full run around. We have to connect Unreal. We could have connected Unreal to all these things. I've already unwired myself. Let's just connect it to the relay and be done for the day. So yeah, I want to do a lot more, but we'll have time. We have a whole semester together. So let's do Unreal, and we'll do a new function of being able to send data from Unreal. Let's just open up my project from class. Which is called, why is it not here? Oh, because I moved it to a new folder. Oh, interesting. Okay. Let's see. We're gonna get into how do you sync projects on the internet later on. But for right now, we'll just make a new map. So we're gonna send a single Boolean. We're gonna so we before we were popping data from the structure. Now we're gonna put data back on. We're gonna start stacking it back on. In the same way you're creating a list, the order in which you pop it back on or push it back on, the order in which you can then pull it back off inside of Max. And essentially, as I get better at this stuff, I want to basically make lists of stuff from Arduino and lists to and from Arduino to Max so that I can just pass anything to anywhere. All right, so here's the project. Cool. You don't need this anymore. All right, so let's go to a new map and we'll call this week 5. Basic, sounds good to me. Assets, maps, week 5. And then let's find something in here. So we can make a VR experience or something like that. We take our player start, move it over to the edge. And the idea is that when we have a trigger box here at the edge, and this is super fun to do it in VR as well, because like when you get to an edge, you would expect the fan to turn on. Let's make it so it's very easy to hit. Anyone who gets near the edge will trigger the fan to go on. Maybe we'll make it a little taller. All heights available to get into here. And so what's the operation we want to do for anyone who's been doing this? You want to get an overlap event in your level blueprint. So with this selected here, and then we'll show the level sender actor blueprint, and then we'll be done. Um, I want to grab a reference to So it's selected my outliner, right? Context sensitive to my trigger box, right click, add an event based off of overlapping. When overlapping, what do I want to do? I want to send OSC. It's not going to work because this is my project from before OSC, which was last week on a different computer. That's fine with me. We'll save. I will find my, this is why live demos are so much fun. I will find my OSC plugin, which is on Windows. Put it in here. Too cool. The problem with this project is that I'm using version control. I'm teaching you guys version control next week. So I'll teach you how to store things. I'll provide you guys with cloud repositories for free. I get them weirdly through my domain provider, and I'll teach you guys how to share projects between each other or between computers. I work on like 8 computers every semester, so I need to share it amongst myself. So plugins, OSC is now installed. Go to our map that we just were at, week 5. Find that trigger box, double click it. Cool. And then open up level blueprint. When I overlap that trigger box, I want you to send OSC. All right. These are all familiar things to us, right? What is the message? So we need to give it a channel. Let's call this one Cliff, the /. So therefore in Max, I need to also get a Cliff. And then the data, I need to give it a value. I can do a bool or an int, right? Because we've established those are both zeros and ones when it comes to Max. So I'm going to now push an int. So give it the value of 1 or 2, no, 1. When I begin overlap, and then I can also, in the same way, when I end overlap, right, when I leave the box, I can do the same thing. Turn it back off and send the value of 0. Where am I sending it? Well, I need to go back to my project settings, look at my OSC plugin, and we are receiving on port 8000. We established that last week. So let's send it on a different port. I can make a bunch of different targets. I can send it to every single one of us. I get everyone's IP address from that collaborative worksheet and send you values from my Max to your, from my Unreal to your Maxes. But for right now, I'm going to do this address, which is the same thing as localhost. 127.0.0.1 is localhost. Right, same thing. The Unreal just to understand the word localhost. I don't want to use port 8000 because I don't want to get my tubes crossed. So I'm going to say 8001. Again, it doesn't really matter. Creative coding is between 6,000 and 9,000. Everything else is like for software to phone home and stuff. But as long as it matches, it's fine. So let's go over to Max, where we can say new UDP receive instead of send. I actually don't need to say localhost because just if you give me anything, I'll take it. But I'm looking only on port 8001. And then I could be getting a bunch of different messages, right? I have a bunch of different addresses. So I'm going to use this object called route. And route's interesting. Route has basically one thing that's called garbage collection. It's if it doesn't match anything, send it out here. The first one is, though, if it matches nothing. I've not said what I want to route. Route's an adaptable object. I just want to do Cliff. And then I can make a whole list of these: route Cliff, route dimmer, or route whatever the address I add. But keep on adding it to this object. Now this first outlet says only give me stuff if it's from Cliff. So there we go. All the data coming from port 8001, only if the message is Cliff, right? If I then did say /dimmer / light, doesn't matter what it is. You'll see that I now have different outlets. It says if it matches dimmer, come out here. If it matches light, it comes out there. The object expands, and I can connect this to my toggle. So now in my world settings, I'm going to go into regular game mode. So just flying around like a regular little, that little ball. It's more fun if we can see it. Let's say it's visible, not hidden in game. Line thickness, we'll make it a chunky one. All right, there it goes. Let's see what's works. So the VR experience, you get to the edge of the cliff. It turns off the projector for some reason. And then when I leave, I'm like, oh, man, it's too windy over here. And the fan goes off. Right? So Unreal to Max Arduino. Cool. So that's the technical demo. Everything was pretty much copy and paste, like a little bit of whatever's. Just try to do the stuff. There's tons of fans around here. We have tons of relays. Get your own, they're fun. The one last thing was something that Charles had brought up that I thought was really interesting, which is how to get OSC data into your level blueprint because it doesn't have this list of components on the side. So you can't get the OSC receiver. Again, this is extra information. If you're already kind of overwhelmed, just kind of shut off if you want to. But I want this information to be documented in the video so you can come back to it later on if it's important. So in your blueprints, I'm going to create a new class called BP level sender. I called it Cindera. It doesn't matter to me. And in here, same thing as we were doing before. On OSC received. And all I want to do is send this to something called an event dispatcher. I want to dispatch it to my level. So we call this one OSC send. Doesn't matter what we call it. Compile. And then we can make some new inputs. One of them happens to be called an address. Address is actually a data type of name. So we will send a new input called name, which is our address. And then we come here, we say we're going to call it. And we just connect these. And see, it has a little letter that's being sent somewhere else. All right, and then we need to make a type of data, and this is a OSC data element structures. Complicated, but look over here, new input. And again, I can send you guys this blueprint. You can just plug in your project and it'll work. So this type is OSC data element struct, and it's not a single thing. It is an array data, and now it matches, and we can call it data, right? It's like the video at the very beginning of class, data. I got its callback. It's not connected. Let's refresh. Is it not correct? It was just being temperamental. So one thing we have to remember to do is put it in the level. And if it's in the level, you can get a reference to it. Right. We have a reference to it. And then we should say when we start, assign that let's drag off. We need to assign the OSC to send. So let when begins. And now we have our OSC and our level. And we can do everything we are doing before, like popping and pushing and all that kind of stuff. We could just say branch, or not even. Yeah, we could say equals hello branch to print the word hello. So this is just prove that it works. Max just needs to send, oops, on localhost 8,000, and we just need to send anything on the address hello. Three pinned hello. There's hello on the top left. Cool. So I'll send you all the scrap. So you're just basically trying to connect it. I don't care what you make it from scratch. You can copy and paste it together. I'm more interested in the connections and start thinking about the whole world of data mixing. Anything could be anything. Yes. This is all recorded. This is the fire, man. Of course I'm gonna record this. This is a jam. So besides is this on the test? Is there any other questions? This is not in the test. This is but life is a test. So yes, this is recorded. We're sending things around again, copying, pasting, relays. Relays is a real important thing. This thing lives here, wherever this thing lives here. $30, super powerful. Get one. We'll use this one later on. But all these other components we now have. If you want to, before you leave today, check out. I can show you. I can do a little tour over there. Show you that we have components and stuff. I'm ordering a whole bunch of RGB LEDs because I wanted to finish doing that demo. And yeah, I'm gonna stop recording.